Okay, sir. Then please start the session.
Just I will take 1 minute time, okay, to start. 1 minute.
Yes, sir. Yes, sir.
Yes, sir. Clearly visible.
Okay. So today actually I'll discuss just briefly the concept of statistics and probability for 15 to 20 minutes maximum. Because otherwise, I could not go to the Python code. And this is the first agenda. Second is, I will show you one file that where we can import the file from, excel.csv. And then I will start my work on that file. Okay. And then I'll show you that one file I'll import from SPSS. Okay. And tomorrow I'll solve some problem on visualization using the Python data. Okay. So quickly I'm going to my what is the probability, because for this data science already yesterday discussed that basically any data science analysis or machine learning or deep learning analysis based on 5 topics. One is the statistics, second is the probability, third is the calculus, fourth is the linear algebra, and fifth is the optimization. So obviously, when we start some Python code using data, so then we need some concept of statistics as well as probability. And as well as linear.
Sir, just a second. Your voice is little less.
Okay, little bit slow. Now it is okay?
Yes, sir. Yes, sir.
Actually, okay. So now, today I will start with in this. Suppose what is data? Just you check, there are 2 types of data is given. One is called the dumb data without any column name. And in the second, the column names are mentioned. So this is basically, the 4 by, there are 4 rows and 3 columns, but column having no name. Yesterday class I have shown why the column name is important. Okay. And basically the dumb data, we cannot say it is a data frame because it conveys no information. But this is my expressive data with maintaining the column name and similarly serial number of rows. Then we can say, okay, this is called expressive data, conveys some information. Now we know the statistics definition. I'm not going in detail. Okay, so this is basically a collection of numerical data, organization, summarizations, and analysis of numerical data. And finally, we go for interpretation of numerical data. Now, so there are actually 2 branches for statistics. One is the descriptive statistics, another is the inferential statistics. Okay. So mainly today we'll show you some descriptive analysis part, statistics part, and some inferential part. Okay. And I will try my level best to show the predictive model. And this is what is the organization of the data. So we can collect the data using questionnaire method, using interviewer method. That's what you know, method of direct observation, indirect oral investigation method. And then this is basically, I'm telling you, this is basically, collection. Under collection, these are the methods. And under presentation, these are the methods. This is the basic method. And graphical presentation of data, tomorrow I will show you in detail. There are 2 types of data. One is the non-frequency data, another is the frequency data. Okay. Then we go for, already I discussed about the univariate data analysis. That is the central tendency, dispersion, skewness, kurtosis. And now today I'll show you the bivariate data analysis as well as the multivariate using the concept of correlation regression. And we know what is the central tendency. From the graph, you can easily understand what is the dispersion. So mu is the mean and sigma is the standard deviation. I'm not going in detail this part. And this is my skewness. Just a minute. Skewness. And that is the distribution, maybe, the departure from the symmetry. So there are three types of skewness. One is called, the positive skewness, symmetrical distribution, negative skewness. So this is very simple. Already I'm telling you, I'm not going in detail. I will give my PPT after my class. So then you can easily understand. And then what is kurtosis? Kurtosis is very important. The question is, say two distribution having the same location, that is the same mean. If we consider those two stock market data and the same dispersion and same shape, that means their mean, standard deviation, and also the skewness also same. So they may differ with respect to the peak or tail area. So that is the degree of pickedness of a frequency distribution is called kurtosis. So there are three types of kurtosis. One is the mesokurtic distribution, which is called normal distribution, plateaukurtic distribution, which is called leptokurtic distribution. And on the basis of leptokurtic and plateaukurtic, we measure the outlier of the data set. So this is basically the measure of central tendency, dispersion, skewness, and kurtosis. There are different types of measures, and these are basically non-parametric measures. And this is the some spatial measures, geometric measures. Okay. And this is, yesterday I will show you why it is important, the graphical presentation of box plot. And basically it gives the graphical presentation of the 5-point summary. That part already I discussed. And not only that, we can the detection of outliers. For the data science, in your data, if there is a lot of outliers, definitely you will not get any robust model. So when you start your analysis, like regression, ANOVA, anything, your machine learning, logistic, clustering, factor analysis. So then, first of all, you have to check, is there any outlier or not? So if there is no outlier, then you can go for the parametric analysis. Otherwise, you have to shift to the non-parametric analysis. Now, this is the bivariate data scatter diagram. You know that is when there are two variables, then we can say it is a bivariate data. And for this, we apply correlation, simple regression, and scatter. And this is the different types of correlation measures. One is the called correlation ratio, multiple correlation, partial correlation. And that's why there are different types of regression, linear regression, polynomial regression, logistic regression, multiple regression, and so on. There are so many regressions. And this is the inferential statistics. This is the very interesting, what is the meaning of inferential statistics? So I like to discuss in a single, 4-word, that is basically, it is the estimation of population parameter with the help of sample statistics. Because parameter is the characteristics of the population and statistic is the characteristic of the sample. That part we know. And there are 4 terms, that means population, parameter, sample, statistics. So that's why drawing condition about the unknown population based on a known sample statistical inference. Okay. And then we come to the preliminaries. We need some concept of probability. Because when you collect the data, it is not certain data, it is a random data. So obviously, there is a concept of probability. And to know the pattern of the data, we have to know what is the random variable concept. And then we have to know some probability distribution. And out of some probability distribution, some distributions are discrete and some discrete distribution are continuous distribution. Then we can discuss about the 3 mainly sampling distribution. What is the chi-square, T and F distribution? And there is so many sampling theory, not I am going that for this. discussing. So these are the basically preliminaries before starting some machine learning concept. And this is probability concept, that part you know, probability. So probability based on some favorable number of cases by total number of cases. And I'm not going in detail. Probability also used for the estimation of the future. We are using some model for the prediction based on the past information to get the future information. So that definitely, similarly, probability also can be used for prediction. So what is the difference between the statistical regression-based prediction and probability-based prediction? Because regression-based prediction, we are using the correlation, basically, which is the symmetric in nature. But the probability-based prediction is not the symmetric in nature. Okay. Why? Because probability of AB can never be, maybe can be not equal to probability of BA. Sometimes maybe. So that is called the association rule. And most of them telling you machine learning estimation based on the probability estimation. There are so many things, naive-Bayes approximation, the entropy, all based on probability. Now, so after probability, and this is a very, very important theorem on probability, that's the Bayes theorem, and by which we can predict the future. Okay. So, and this is my next part. We have to know some statistical distribution. Already I told you that we have to know some discrete distribution, which is called countable finite or countable infinite. Like binomial distribution is the countable finite, and Poisson distribution is the countable infinite. Okay. So these are some basic discrete distribution, and these are some example of distributions. What is statistics? From this example, you can understand that this is very interesting example, that we are tossing a coin and let A is the number of heads, number of heads, that is the event. And if we toss the coin 10 times, so there is a chance that we can get the 7 heads. So that means what is the probability? That is the 0.7. But if we toss the coin 100 times, so there is a probability 0.61. And in this way, if we increase the number of tosses from 10 to the power 1, 10 square, 10 cube, 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7, 10 to the power 8. So definitely, then the probability gradually tends to 0.5 to prove the unbiased one. So this is a very interesting example. That means, if we go for the large sample, so our result will be more approximate to unbiasedness. And this already I told you what is random variable probability distribution, and some commonly probability distribution we are using machine learning. So some discrete distribution like binomial Poisson, geometric, hypergeometric, negative binomial distribution. And some continuous distribution, we are using normal distribution, rectangular distribution, exponential, gamma, beta, log normal, Cauchy. So why I have given this so many distribution? Because maximum in case of stock market data, we need so many types of distribution. Okay. In case of optimization, we need the beta distribution as well as the normal distribution. Okay. So that's why in some cases we need the hypergeometric distribution. So these are the some commonly used probability distribution. And I'm not going in detail. That is the binomial distribution. This is the binomial distribution figure. This is binomial distribution property, binomial distribution, Poisson distribution, and approximate application of Poisson distribution. It is given where we can apply Poisson distribution. Everything is given. After getting your PPT, just you read it. Okay. And this is the normal distribution property. This is very, very important because maximum case, suppose I am solving regression analysis. So since the regression based on data, so definitely there are some approximations, there are some assumptions. And these assumptions, first assumption is your data set at least follows approximately normal distribution. Okay. So this is very, very important distribution for data science, normal distribution. And then there are different applications, mainly the central limit theorem. And this is the shape of the normal distribution. It is the bell-shaped distribution. Okay. And that part, for that is the introduction, growth, maturity, and decline. And that is the effective range of normal distribution. That part I'm not going because this is called the Chebyshev theorem. And mainly the Chebyshev theorem used for finding the outliers for the non-parametric data. Okay. And from Chebyshev, we understand that this data set follows the normal or not. This is a very interesting distribution. And that is the sampling distribution. And this is, I'm not going in detail. Okay. And chi-square distribution is very important distribution. So with this, and today I'll show you some problem of T distribution using Python, some problem of chi-square distribution with Python, some problem of using F distribution. And this is the finally this is the F distribution. So this is the all about your today's class. And after this, first you start with the how to import the CSV file and how to import the SPSS file. And since mainly you are worried about regression analysis, I know. So first we start with the regression analysis with a very interesting example. And with that example, I'll try my level best to give the concept why Python is important. Okay, and what type of libraries we have to import for the running the regression analysis. So up to this, any question you can ask me because then we'll go to the Google Colab.
As usual, sir, I have one question.
Yeah.
Sir, आपकी जे tossing you showed the tossing for 10 times, 7 times head is coming, and for 100 times, 61 times head is coming, and when it is 10,000 or some 1 lakh, the probability was 0.53.
Yeah.
Okay. But sir, the opposite can also happen, but within 10, there is only 3 times head come. This also can happen.
Exactly, same thing. Because your question is 7 times head means the 3 times tail.
Yes, yes.
That means same thing.
The opposite can also happen.
Because already we define A, B, the event.
Okay.
We are searching for the A, not for the B.
Okay.
We are searching for the success, not for the failure.
Okay.
So I'll give this PPT to all of you. Today I'll give you. It's a very interesting PPT. Now, just a minute. This is complex. Just a minute.
Okay, sir.
now coming. Okay. Just a minute, it is coming now. First, to tell me it is visible to all of you?
Yes, sir.
Okay. So today I will start first how we import .csv file. And after importing the CSV file, then I start to show the basic regression analysis. Because regression is fantastic in Python. And I'm telling you, for understanding regression, mainly you have to know the correlation concept. And mainly then you have to know the R-square concept. You have to know adjusted R-square concept. So many things. So regression using Python, it is also a course. I'm telling you, regression using Python. Because why? Because if we want to start regression, then for regression analysis, at least you have to take simply 1 day or 2 day class. Then I can show you the Python. Then anyone will understand. Because you know the every meaning, every symbol of the output. Okay? There are so many output will be coming. So I am opening my Google Colab. You can open also. So just you check, is it visible to all of you? Hello?
Yes, sir.
Yes, sir. Clearly visible.
Just try to understand. I'm importing, the first line is very important. I'm importing from google.colab import files. This is the first line. And what is my second line? Now we have to upload the files to the Google. So these two commons, those two lines are same in any programming. Maybe you can run, you want to run ANOVA, you want to run PCA, you want to run clusters. So, and you need to import the file, CSV file from your some destination in your laptop. Okay. So because you know that where the file is saved. So first we from google.colab import files. And already I have given that file to you after first class. The name of the file I am showing, then easily you can do that. So from google.colab import files, I'm running this command. It takes time. It will take time in the first line. Actually, it is depending on the network speed also. Yeah. So now it is okay. Is it clear to all of you? This is the first line is very important. That from google.colab import files. Okay. Then we upload it. This is equal to files.upload. The command is same for all applications. So when you select this, then your choose file will be coming. So this is my all CSV file. And definitely I need the selling price. So I select it and open. Is it okay? And this file already I have sent to you. Hello.
Yes, sir. It's okay.
Okay. Okay.
Yes, sir.
Very nice. So, and definitely, so what is the first step? And because try to maintain some template for any kind of, Python coding. Say, if we want to run principal component analysis using Python, there is a template. I'll discuss tomorrow class. When I end the class, I'll discuss about the template. That means if you know the theoretical concept of PCA, so since the template will be available in Google, so easily you can solve PCA using Python. And if you can ask me, sir, how you learn this thing? Because at my age, seriously speaking, I'm consulting with only Google and some books. And I try to get the template of each, the methods. Suppose a clustering method, there is a template. For optimization method, there is a template. There are naive-Bayes, there is a template. But if we put the template and put the data, suppose naive-Bayes data, automatically results will be coming. But if we don't know the concept of naive-Bayes, we will not understand how. Am I clear or not?
Yes, sir.
I can give the template of all, full template of time series analysis. But you have to know, suppose what is the template of time series analysis? There is ARIMA, there is the GARCH model, there is the LSTM model, so many things. And there is a very interesting concept in Python that using the different libraries, you can extract your data from yahoo.com, moneycontrol.com. That means from the external source, you can import the data. So not only the CSV file, not only the SPSS file, not only the Python file, you can extract from the external sources. So that advantage also you will get in Python. If I get time, I will show you that command also. How we can extract, your external data set. Okay, which is very important. Suppose I'm telling you why it is important. Suppose I have no the Prowess software, but I need the Prowess data set. And if I know the, the head of the Prowess data set, stock market data, I can easily import. Okay. So this is my first step, import. What is the second step? Because in case of regression, so many things we require. Because regression is the basic of machine learning. Basic of machine learning technique. So for regression, we need a data frame, we need the pandas. Since there are so many calculations like, linear algebra, number, so that's why we have import NumPy. We need some scattered diagram, so matplotlib. We need so many types of distribution plot, that's why we need some Seaborn. Tomorrow I'll take the detailing class of Seaborn. And we need some statistics like correlation, the PIF, so many things. So that's why from SciPy, we have to SciPy import the stats. We from Skylearn, that is the machine learning concept, import the data sets and linear model. Linear model. From Skylearn linear model, import the linear algebra. Why? Because in case of regression, sometimes we need the eigenvalue. That's why we need to take the help of linear regression. Import the stats model, API SM, for running the output of regression model. and from SciPy import stats. So these are basically when if you import 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, install some packages on libraries. Maximum 12, you can run so many things. You can run regression. Again, you can tell me, sir, how you know this thing? So one day I went to Google. Simply I open Google and I write for running the multiple regression using the linear algebra concept, and using I want to know the BIF concept. So what type of libraries I need, and Google, and then I am starting the very simple style. Okay, and definitely I have to consult with some books also. So we run this. And just you think, you check the arrow, that means this is importing. 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 Now, I did stat. And now it is okay. I hope it is clear to all of you. So every libraries I have imported. First of all, I import my CSV file, then import a libraries.
Sir, ফার্স্ট স্টেটমেন্টটা বুঝতে পারলাম না from google.colab import files মানে what is the significance of this statement?
Because selling from Google Colab, I like to import files because if I, I'm telling you, suppose if I do this thing in the Jupyter Notebook or Anaconda, so directly I can install the package library.
Okay.
But since I am taking the help of Google, and it is the the free open source of Jupyter Notebook, so obviously I have to import the file.
So what type of files, sir?
Already I told you CSV file.
Achha, CSV file. Okay.
Already you check the name of the CSV file. Already and definitely the selling price.csv in my laptop some destination. I know the destination.
We have to upload that.
You just upload that. And after uploading, you have to import this so many libraries.
That I understood.
So number after 3. So I like to know, this is the step 3 is complete. So I like to create the data frame from this file. What is the data frame of this file? What data frame means? That is how many columns, that is how many variables and how many rows. That is the data frame. And for the data frame, already yesterday I have shown, we have used the pandas. And pandas pd.read_csv. And what is my file? Selling price. And just to check, this is in the first bracket. That means we are creating a tuple, not the list. That means we can which is imported, we can never change. Okay. And if we change again in the file, you go to the file, then you change the data, then you can import the file. Okay. But after importing, you can never change the data. So just run this. That means okay. That means my selling price, all variables saved into DF2. And obviously we run DF2. And this is my DF2. That is how many variables? 4 variables. How many rows? 10 rows. Because in Python, first row is 0. And that's why 0, 1, 2, up 9 means there are total 10 rows and 4 variables. So you can ask me the question, why I have taken these 4 variables? Because we know when you run any kind of model, so there are one dependent, more than one independent. If there are one dependent, one independent, basically it is called simple regression. Because one dependent, one independent. If there are one dependent, more than one independent, that is basically called multiple regression. If there are more than one dependent and more than one independent, then it is called the classification problem. That part today I am not discussing. So These are the variable cell size edge AP. And these are this thing. So now, when you get this, so I like to know what are the information. Information means, in the yesterday I have shown this. So what is the information means? That is how many data, how many variable, and what is their data type. What is their data type? So we want to know information for DF2. So DF2 dot information, and this is the information. That is, there are 4 columns, and there are total 10 rows. All are non-null, that is no missing, and the 3 are integer type, and 1 data type is the float, because there are some fraction decimal point. So that is the information about the data frame. So today I am not, just a minute, just a minute. Just a minute. I like to, I'm not sure. Say, you can, why I have done it. Okay, why I have done it. Okay. Actually, for experimenting, I have done before. I have to change it. That what today I will not discuss. That is basically the categorical variable concept. Okay. So I have to delete it. Sorry, I have to delete it. Otherwise, the problem for understanding. Just give me some time. Huh? I'm changing. I'm changing the name of the data frame only. Is it okay? Hello.
Yes, sir.
Okay. Because today I will not show the concept of dummy variable, because when you solve the logistic and so on, then I need the dummy. Case of regression also, but I am showing the simple regression as well as the multiple regression. So DF1, very nice. So this is my 4 variable. Now I am telling you can say, so how we get this, model, how can it this thing? So basically, I'm showing it. This is the DF1. Yeah. This is the VIF, variance inflation factor. And this is okay. Just first we run, then okay. Just to think, we have considered the 2 independent variable, size and age. And this degree DF1, and this is variable called X. So I'm just a minute. Just a minute. Say selling price is a function of size. Say. What is the meaning? That is, if size of the house increase, then selling price will increase. If the size of the house is decreased, selling price will decrease. So this is a positive relation between selling price and size. But if we solve this problem, you get R square only 0.66. So what is the meaning? That is the 66% of the variation of selling price can be explained by size. So what is what is 1 minus R square? 34% not explained. So automatically the question is how we can improve R square. So then we can try to, consider the variable from the domain. Because selling price not only depending on size, also selling price depending on the age of the house. So that's why I introduce another variable, age. So there are two variables. And when there are two variables, there are so many assumptions that two variables having no multicollinearity. That is, there is no high correlation among two variables. That is simple assumption. Okay. There are minimum 4 assumptions you have to follow. That part tomorrow I'll discuss when you go for visualization part. So what is the main objective? How to improve R square. So then, and we select how we calculate the VI, that is the what is there multicollinearity occurs or not. I'm not going in detail. I'm telling you this is basically the Python class. I'm not going in detail in statistics. So we consider X is equal to, there are two independent variables, size and age. Also, already the documentation part is given. That is the independent variable set. And for calculation of, and try to understand, already we import this model, stats models, not stats, finding the outliers influence. There is the import variance inflation factor. So definitely we are importing this module. Okay. This module we are importing import this model from these stat models. And this is the documentation of BI data frame. That is, what is the BI data frame? Since that is the BI data frame, we apply the pandas. And pandas, and we calculate the BIF data. There are two features only X dot colors. And then calculating BIF for each features. Okay, why each features? Maybe for some problem, there are 5 independent variables. Maybe from 10 independent variables. So that's why we apply the for loop, and then print BIF. And when you get this, so there are two features, size and age, and their BIF is highly correlated. So there is a huge multicollinearity occurs between two variables. Because it is obvious, there is a huge high relationship between, because for the BIF is more than 5, more than 2, there is a high multicollinearity occurs. Okay. So now I want to get the correlations. So better you give the DF1, because already I have changed DF2 to DF1 and select this. We get the correlation matrix. Is it okay to all of you?
Yes, sir.
And just you think, this is your size and this is your age, and size and age are highly correlated. Highly correlated. Okay. Size and age are highly correlated. And if you check the selling price only with the size, this is the correlation is high. But if we consider only age, the correlation is less. try to, this is very, what is the interpretation of correlation matrix? Because the selling price of the house is a high correlation with the size. It is obvious. But selling price, if we take only age as a single variable, the correlation is less. But if we consider the two variable, then definitely R square will improve. That part I will show one by one. So I want to know the concept of normal distribution, because there is a very interesting property that for the normal distribution, mean, median, mode are same, and skewness 0, and excess kurtosis is 0. Excess kurtosis is 0. What is excess kurtosis? Now 3 minus. Excess kurtosis means the kurtosis minus 3. Because we know that for the normal distributions, kurtosis will be 3. So definitely, if we get some excess kurtosis is 0, that means your original formula of kurtosis will give the value 3. That's why 3 minus 3, 0. Okay. And if you get excess kurtosis equal to 0, that is called normal distribution. And if you get excess kurtosis is negative, that is called the plateautic distribution. And if excess kurtosis is positive, okay, positive, that is called the leptokurtic distribution. And on the basis of what is the implication of this skewness kurtosis, I am telling you, on the basis of skewness and kurtosis, we can determine the result. If your skewness values are very high, if your kurtosis value are very high, 10, 15, skewness is 8, so obviously that in that case you will not get the good robust regression. Okay. Because your data set will not follow the normal distribution. So that's why this kurtosis is very important. So DF1, and we run DF1 skewness. So these are the skewness value. So what is the skewness value? Overall degrees of skewness is 0 is coming. And cell, this is the skewness of cell for individual variable, size skewness, age skewness, and epic skewness. And similarly, we can get the value of kurtosis, df1 dot kurtosis. We get the kurtosis. Okay. Now, very interesting. I want to know the full description of my data frame. Full description of my data frame. So yesterday class I told you. So full description of the data frame means the 7-point summary. So what already I have discussed skewness and kurtosis, and we did that 9-point summary. We discussed 2 points, skewness and kurtosis. And if we select this diffuse under describe, so it gives the 7-point summary. For each variable, we get mean, standard deviation, already discussed, 7-point summary. So, and then again, I need the information of I'm repeating this only for understanding. Information of DF1. Again, there is the 4 variables, 10 rows, 4 columns, and these are all, integers, and assess price is the float. Up to this clear?
Yes, sir.
Sir, VIF to just 1 second bolben. VIF data calculation basement.
Actually, VIF calculation, okay, I'm trying to explain. Say, Y is a function of, say, x1, x2, and x3. See, so there are 3 independent variables. Actually, we are calculating multicollinearity among the independent variables,
Okay.
not the dependent. That means x1, we can consider a function of x2, x3.
XTX3.
Obviously, if we run the regression, we get R1 square. That is how much X1 can be explained by X2, X3.
Yes, sir.
And if this R1 square is very high, there is the multiplicity of us.
এটা কখন শেষ হবে?
And that range is
15টা। তখন খাবারের অর্ডার দেবে? তখন খাবারের অর্ডার দেবে?
Can I start now? Some noise is coming actually.
Yes, sir. Yes, sir. You may please.
So these R square, if greater than equal to 0.5, then high correlation. And VIF measured by simply 1 by 1 minus R square. I hope it is clear.
Clear. So it should be calculated for each and every variable, X1, X2, X3.
Definitely, but ultimately, for each variable, they will give BIF. And when you go for, I will show you the another example, then you can understand
Yes,
what
sir.
is the application of BIF. And from the value of BIF, in
Mhm.
case of PCA, we can determine which variables will be reduced, which variables will be discarded. So
Okay, sir.
BIF will take a very, very important role for the dimension reduction. Okay.
Okay, sir. Okay. Absolutely.
So,
Okay.
so now so this is the description. And this is the information of DF1. Now, I'll show you one or two plot. Question is why? Because in case of regression, we have to check that the dependent variable follows the normal distribution. So, this type of visualization we can cover from Seaborn library. Seaborn library. And Seaborn short name is abbreviated as SNS. So from SNS, we try to draw the distribution plot and form the DF1 only for the variable cell, because cell is my dependent. So again, repeat, SNS is the short name of C1. And from C1, we like to draw the distribution plot. And where from the DF1, that is my data frame. And this data frame only we like to show what is the distribution plot of cell variable. And we try to run this. So this is the distribution. And definitely, this is basically histogram. And this is the density plot. And if we draw the density plot, it looks like a normal distribution. Is it okay?
Yes, sir.
So that means the values of cell along the x-axis and the frequency density along the y-axis. Okay. Now we are thinking, what about the distribution of the independent variable? So that is a same thing. SNS dot distribution for this is same, and DF1 is same, and we are changing only the variable. And just to check, and we given in the first bracket, that means we can never change the values of the size. And that is the distribution plot of size. It's not like a normal distribution. Toward, positively skewed data. And why this? That's why I am calculating the skewness value. For size, the skewness is positive. For cell, skewness is negative. For age, skewness is tends to 0, nearly 0. So naturally, if we draw the another diagram of age, distribution plot, it looks like a normal distribution because its skewness tends to 0. Okay.
Sir, one query. Sir, while I'm doing that in my Google.Colab, this normal distribution line is not coming.
In
This
Google.Colab,
polygon. When I am doing based on the code you are showing us, but in my
okay.
machine, this polygon is not coming. Only the histogram is coming.
Okay, this part is not coming, the curve. Okay.
But I am giving up to this, it is okay. But right now,
Okay.
same thing,
When
SNS.DisPlot.
you have given the command sns.distribution
Yeah.
plot, but
Ha,
your
ha, ha.
your and along y-axis what is written?
No, that name is not coming count that I have to give actually. So
No.
this definition I didn't give. That we
No,
have to define.
my question is after giving this command, okay. So definitely this graph will be coming.
This is
Because
count is
I'm telling
coming
you,
actually.
because just to check in the output, at the x level is the age and y level is the density. It is coming.
That we have to put.
Why I will put it? That no, I'm not. This part it is
No,
coming.
you
I am
didn't
not
put.
giving.
Yeah. No, that's not coming actually.
No, this part I have not given. I have given only this command.
So then probably I didn't incorporate that. What library I have to import for this SNS plot?
You have to import the library SNS.
Okay.
Seaborn as yes, Seaborn. You have to import Seaborn as SNS.
That I did.
Otherwise, this graph will not be coming.
No, that I did, but still okay. I'll check once more.
Okay. Thank you. So this is my okay. Now I am coming to already distribution plot of size, distribution plot of age. Then I am coming to very interesting part that I know the cell depending on size. Is it okay? Cell depending on size. That's the two variable. And we are considering this data from DF1, my data frame. And this the concept is called SNS common dot. This is called the joint plot. Then that means what you have to know that what is the difference between distribution plot and joint plot. Distribution plot for the univariate, joint plot for the bivariate. That means in case of joint plot, we consider two variables. One is the dependent variable and one is the independent. So when you select this, that SNS dot joint plot, again, first bracket, x, that is the leveling of x equal to size. This is called the argument, y equal to cell, and data equal to f. And definitely SNS dot joint plot acting as a function. Already I defined that functions having some arguments. So when you run this, we are getting this. That is basically, this is the scatter diagram. Basically, this is the scatter diagram. And upper part is the distribution of size. And this part is the distribution of cell. That's why it is called the joint plot. That means through joint plot, we get the scatter diagram as well as the distribution. Is it clear? Hello. Hello.
Clear, sir, clear.
Now, I want to know the regression from graphical. From graph, I want to understand the regression. So we give the SNS dot join plot, x equal to size, y equal to cell, data equal to df1, and I want the regression line, that is the kind equal to regression, REG. So if we run this, we get this. So this is my regression line. Clear? And that is the sum points, because already I told you that initially I have 10 points. 10 points. Just you check how many points? 1, 2, 3, 10 points. And out of 10 points, the 4 points, 4 are more or less 3 and 4 are very near to the regression line. So, and some points are above the line and some points below the line, and 1 point is far away from the line. That's why error is high. Okay. And if the maximum point lies on the line, definitely R square will be high. So from the graph, we can understand that R square is not so good. And then we can go for same thing. Why there is no good relation between age and cell? Because maximum points far away from the regression. And that part already discussed in the correlation matrix.
Sir, in these plots, we are plotting age with cell, size with cell. Is there an inherent consideration that y is a dependent variable, or it's not like that?
Obviously, when you tell the story, then you have to, from the story, you will know that definitely sales price is depending on size and age.
If you
Sales
touch
price
this
is
wall, you die.
dependent.
Okay.
Can you understand?
Now I'm coming to the very interesting types of visualization, that there is a pair plot. So we know the pair plot occurs between the scale variable. So when you consider DF1, there are total 4 scale variables. One is the selling price, size of the house, age of the house, and access price of the house. And pair means, so if we select this, clear, this is called pair plot. So what is pair plot? Diagonals are the distribution plot. Diagonals are the distribution plot, and off diagonals are the scattered. So definitely, this is the scattered diagram of sale and size. This is the scattered diagram of sale and age. This is the scattered diagram of sale and access price. So there are, obviously, since there are 4 variables, all are scale variable, and we get a 4x4 matrix. And how many diagram? Total 16 diagram. And out of 16 diagram, that 4 diagonals are the histogram. And definitely we know the correlation matrix is a symmetric. So correlation between sale and size is same as size and sale. Just to check, the diagram is same. Okay. It's a symmetric relation. Here it is xy, yx, here it is xy. but the diagram will be same. Now, now this is very interesting. I'm going for multiple regression model. So for the multiple regression, we need dependent variable and more than one independent variable. More than one independent variable. So I'm telling you as a homework part, because today I will send you. Then one thing you can do it. I will not do because the time is a constant. So instead of age, only you take size. Only size and Y cells. Then you run this. So that is called simple regression. When you get the output. But here we take the two independent variable, which is saved as X, and one dependent variable, which is saved as Y. Okay. So this is the data frame of Y, and this is the data frame of X. So we run X, we run Y, okay. And this is my very interesting part, that we are giving just a minute. Age, given Y equal cell, okay. Now we are writing SM constant X2. SM means stat model. We are at constant. At constant means we are getting the model Y equal to A plus B1x1 plus B2x2. That is my at constant intercept. And we apply the OLS method. OLS method on YX2. Okay. And estimate, that is the estimate model fit, and we need the summary. Okay. We go for this. Again, repeat. We take X, the two independent variable, and that we apply the stat model after adding the constant, which is saved as X2. We apply the OLS method on Y and X2, because here X2 means size and age. And we estimate 2 means we get the fitted model, that is after calculation of the constants using the least square method. And then print estimate 2, that means we are getting the summary, print or summary. So we run this. So just to check, these are total output. These are total output of OLS regression model. So I hope, actually there are so many things you have to know already. I told you. That means you have to know the F statistics. You have to know the R square. You have to know the adjusted R square. And you have to know what is the meaning of residuals. You have to know. That means you have to study regression in detail. And this is already T statistics. Already I told you. And that is your confidence interval. And that is your Darwin-Watson, basically used for time series data. That's the Jarque-Ubera test used for the normality test. Okay. And this is the value of skewness of the model. That is the kurtosis of the model. And omnibus test for the homogeneity of the model. Not only that, if there is a multicollinearity, that also given the notes. Also given the notes that for the model there is a multicollinearity that already I have proved. Okay. So in this way, I am getting the regression model. So there are two types of regression model. One is with constant, and another is without constant. So definitely without constant, your R square will be very high. R square will be very high. So if I write this, So automatically OLS model SMYX, your R square will be, and same thing, you can give the summary, you get the summary. Here R square is very high. Just to check, R square is very high. That part I am not discussing today because it is detailing about regression. So now if any question you tell me, then I will show you that how to import a file from SPSS. Hello. Clear? Hello.
Yes, sir.
So now I'll show you that how you can import the file from, because maximum you are using SPSS. So definitely, say you want to run factor analysis and you have the file in SPSS. So how we import the file SPSS from SPSS to Google Colab? Very interesting. So that's why, and that file also I have given to you. Okay. So that file, we go to Open Notebook. Open Notebook. That is the installation SPSS. Is it clear? How we install the SPSS? My SPSS file name is BSE underscore sensex underscore factor dot sap. Sap means SPSS file. But there are some difference when you work on CSV file and when you work on SPSS file. Just a very slight difference. Otherwise, SPSS file will not work. So it's the same thing. There's the form google.colab import files and uploaded files uploaded. Just we done this. Yeah, now we can choose the file. So here is no SPSS file, all are CSV files. So I have to go to the SPSS file. So we go to that backup D. So this is yeah. This is yeah. This is my SPSS file. BSE underscore sensex underscore fact. Open. Clear? The file is selected. Is it okay?
Yes, sir.
And now, what is the step 2? Import the same thing. What is the step 2? Import the files. And same as like regression, all files, seems I copied this thing and run this. Clear? But since then I have to create the data frame. Next step. So in case of CSV file, we have given only DF1 and then it is called PD, that is pandas dot read underscore CSV and name of the file. But since it's the SPSS file, there are two change. One is the library is changed, and that's why we import this PyRead stat, because SPSS file is completely a statistical file. And we write df1 comma meta. df1 comma meta means this command is very important. Actually, when I am starting, so I was so puzzled, I could not run any SPSS file in Python. So then again, I take the help of Google. So then I have written clearly, yeah, I want to run SPSS file in Google Colab. So what is the command? So then and then Google has given this command. So definitely when Google has given this command, Google is given this command not like this way. Google has given this command, you write data frame, meta. Your library is this, and then the read underscore sap and name of your SPSS file. Because Google not possible to know my file. So this is, you write it. It is very, very interesting. There is the df1, meta, the pyreads stat dot read underscore sap and name of the file. And if you run this, it will come in. I'm telling seriously, without meta and without this pyread stat, I have given PD. PD means pandas. Because I know from the pandas concept from the previous class, if we want to form some data frame, I have to use the pandas. But in case of SPSS, it is failed. So then I have taken the help of Google. And this Google has given, I have written, I got this. And then my analysis is very simple. Because again, I select the df1. And df1 has come. Is it okay? Hello.
Yes, sir.
Yes, sir.
So after coming df1, and we get so many rows and so many columns. So very interesting part. Then we try to get the df1 correlation. And we get a huge correlation matrix. But question is, there are so many variables extra which already needed after the factor analysis, which have come after factor analysis. So by any means, we have to discard those variables like factor 1, factor 2, factor 2, again factor 1 underscore 2, factor 2 underscore. So that is the 4 variables are extra. So originally, how many variables? These are basically the macroeconomic parameters. How many macroeconomic parameters? We have taken 10 macroeconomic parameters. And out of this, Sensex is the dependent variable. And gold, these are all independent macroeconomic parameters. So after getting these correlation matrix, so we have to drop some variable. So again, I am telling you, by mistake, I have dropped only 3 variables. That is a mistake. Because I have to drop the 4 variables. And so definitely when you run these, we are dropping how many variable? Factor 2, factor 2, 1, factor 1 underscore 2, but there is still 1 variable. We have not dropped. Then what I have done this, I have dropped the 3 variables. No problem. I can write now here, but I am showing, suppose if I have done the mistake, then how can I overcome it? So I have dropped this, dropped the 3 variables. So when after dropping, I want to know what is my data frame. This is my data frame. So now the data frame containing this variable, which is not dropped by my mistake. So then what I have done, so again, from data frame df1 drop that variable. df1 drop that variable. And now we get the df1, that is the 10 variables. Now this is my data set. This is my data set. that is Sensex goal. There's the 10 macroeconomic parameters and 39 observations. Now we get the correlation matrix. We get the correlation matrix. So correlation matrix among the 10 variables. So definitely is the 10 by 10 correlation matrix. And so I want to know, because so many things we have to compute, because there are so many, what is my objective? Objective is that there are so many variables. There are 9 independent variables. And from 9 independent variables, some variables maybe are not important to predict the dependent variable. So then what we can do that, we import another function or another module, Pearson R, and that is for the SkyPy. And I'm telling you everything I calculated from Google. And some, I told you some taken from books. So this, we get this. And what is my DF1 information? Because already I get my complete DF1, which containing only 9 independent variable and 1 dependent variable. So DF1. And this is my 10 variable out of this Sensex. And there are total 39 rows. No data is missing. And all are the float type. That is, all at the float type means numeric values. And that's why, since all are the float type, that means that's why you can create the correlation matrix. So now we calculate, already I told you why you calculate skewness. We calculate the skewness of all 10 variables, like same as before. We calculate the skewness kurtosis of the 10 variables, same as before. And simply we get the, the distribution plot, same as before. I'm not explaining because that part same as before. We can easily join plot between dependent variable, my Sensex, with the goal, individually join plot. There are so many join plot, and we can only, I have shown only then the pair plot. It takes time because it's 10 by 10 matrix. There are total 10 variables. Yeah, 10 by 10 matrix. Is it okay? So diagonals all are distribution plot and off diagonals are all are scatter plot. That is basically pair plot. And after doing player plot, so again I have given the correlation. Just check. Then I am showing a very interesting part to you. So then I am taking, already I told you that data science not only based on statistics, probability, calculus, because already I applied calculus for the OLS method. Already I have applied probability for calculating the p-values of model and testing of hypothesis based on probability. Normal distribution based on probability. Okay. And already I applied statistics. But I have to apply some linear algebra concept. Okay. So what is that? That's why, again, we need some sub package, you can say, or sub library, or you can say live module also. From import SkyPy, and import from SkyPy, import linear algebra. And from NumPy also, import linear algebra as LG. This is the short name of linear algebra. So for, I'm telling you recently, there is a course only on linear algebra using Python. There is a course only linear algebra using Python. This is fantastic. That means you have to know so many things. You have to calculate what is matrix, what is eigenvector, what is the inner meaning of these, what is the interpretation of these. Okay. So it takes time, naturally. And then what is the meaning of inverse? Why we applying inverse? What is the meaning of decomposition? So many part of linear algebra will be coming. And how we can linear algebra can be connected with your different machine learning techniques. Nowadays, this type of program, workshop is coming. Okay. So that's why I import the linear algebra. So after importing linear algebra, so we create, because correlation is a matrix, but this is not in the array form, not in the linear algebra form. So I have to convert the total correlation matrix is a array form. So that's why we take the help of linear algebra. So we create this, and then we get matrix. So this is your same correlation matrix. We convert it into, linear algebra matrix, array form. Why this? Because if we can convert into, this array form, then easily we can calculate what is my rank of the matrix. So definitely, since it is an array, that's why you can calculate the rank of the matrix. What is the meaning? Meaning is, when you create an array, it is the 10 by 10 matrix. So 10 by 10 matrix means maximum rank will be 10. So here we get the maximum rank. So if the rank is reduced, so definitely we are losing some dependency. And that part, why this is used in some machine learning technique, discriminant analysis. Very interesting. Using this, they are calculating which variable is important or not. Okay. Then we calculate the determinant of the matrix. That is the determinant of the correlation matrix. So we calculated the determinant of the correlation matrix. And just check that the determinant value, and definitely this value of the determinant, value of the rank, this is coming from your NumPy library. That's why I have used the np.NumPy library. And the value of the determinant, if you check the result, it is coming nearly 10 to the power minus 5, that is tends to 0. So what is the meaning of it? If the determinant value tends to 0, that is the high multicollinearity occurs among the independent. Up to this clear?
Yes, sir.
Yes, sir. One query, sir. In SPSS, we used to calculate the significance value of the correlation. That's the feature of SPSS. While we are going for PR correlation. So can I
I am telling you, very nice question you asked. SPSS calculating the correlation value with the p-values. Okay. But if we go to Jamovi also calculated the correlation value with the p-value. But if you go to some R language, then for that calculation of the p-value, we have to import some other library. Okay. Like,
okay, sir.
For a very nice question. For calculation of p-value in R, we are using the R called, HMIC library. Okay. Then we get the value of p-value. Similarly, in Python also, to get the p-value, we have to install the other libraries. Okay. And that part, seriously speaking, I have not given. Very nice question.
Okay, sir. Okay, sir. That's our part. We need to learn by ourselves.
Very nice question. So now I am showing for the beginners, basically, I have solved this. If for the regression, simple regression, say I don't know anything. I don't know any package. I don't know any library. I know only some, tell me what is it? I know only the data structure. And I know one thing, that we have to calculate for the two variable, what is my slope, what is my intercept, intercept. Slope is the coefficient of x. Intercept is the constant part. What is the value of R? What is the p-value? What is the standard error? So, we have taken some list with x, which is treated as x, and some list treated as y. And we have slope, intercept, we have to find this. And for this, we apply some function. Define function, we are passing x, that is the x is the parameter, and return slope star x plus intercept. This is my regression line. And what is my model? Model is, we are using that we have to find the mapping between my function and x. And we need the scatter plot diagram. We need some model with my x, and then we have to plot show. So this is a very basic simple regression model. And from where we can get the value of slope intercept. And for understanding what I've done, we simply run this. We get this result. So when you get this result, we get the scattered diagram between x and y. Between x and y. Then we want to know what is the value of r. That's why no function is defined, only print r. So then if we run, this is the value of r. R is very less. Very less. Then we want to calculate the NP dot trace matrix. Trace matrix. Okay, that part, just a minute. Yeah, you come to here. Sorry. Not trace, this is for the matrix. Then after calculating of R, we calculate P. That is the P. That is the concept of P value. And if you know the P value, here is highly rejected the model. Why? The R value is very less. R value is very less. And why highly rejected the model? That the P value is tends to 1. That is the highly accepted the H0, where H0 is population correlation will be 0. Then we calculate, individually I am calculating. Then we calculate the only slope. Then we slope. This is the slope value. Tends to 0. Then we calculate the intercept. This is the constant. And then we consider the standard error. So one by one I am calculating only for understanding. And finally what I have done, we calculate all slope, intercept, R, P and standard error. Because I am the beginner, so to understand. So after understanding the simple regression, then we go for, the multiple regression value. Today I am not showing this. Basically, this is considering, the multicollinearity concept. That's what I am coming. Because already we know there are total 9 independent variables. And which is treated as X. So in case of machine learning, for the social science research, you have to study supervised learning. You have to study unsupervised learning. And definitely you go for machine learning detail, you have to study reinforcement learning. Okay. So, but today I'm discussing, initially started with the supervised learning, where we get one dependent variable and more than one independent variables. But now I am discussing about the unsupervised learning where there is no Y. My question is, when this unsupervised learning will occur? So that's why I have taken all 9 variables as X. And we go for X dot head 10, that is the first 10 records will be coming. Because X is my data frame. And from data frame, we get only the first 10 records. If we put if we get the blank, you get the first 5 records. And we need the information of X. Already know information of X. And we know the description of X because X is my data frame. description of X, 7-point summary. We need the standard deviation of X. Standard deviation of X, all variables. We need the, now we convert Y sense X as Y. Sense X as Y. And then we want to know what are the last 10 values of sense X. Last 10 values means last value is 38. That is, there are total 39 observations. Okay. And then we can calculate again X dot correlation. X dot correlation means only the correlation between independent variables. X dot correlation, independent variables. Then we calculate, you take an X dot, this Y is sense X. Then we go for regression model. Regression model, fit X and Y, already we know, and we calculate the regression coefficients. So these are the coefficients of 9 variables. And from these, I'm telling you, so I'm not going in detail because it takes time, because I like to show some other things. And from these, we can find again the regression equation. We run so many coming, everything will be coming, and this part will be not solved actually. Up to this is solved, the regression model. Okay. So just a minute, I am showing my one file. Actually, I am used the same file as a CSV file because someone having no SPSS. So that's why I have sent this file as a CSV format. How is same way? Same way. And if we repeat this process 3 or 4 times, your Python will be very simple. Very simple. And always in your paper, you write your paper in Python code. Okay. So now, yeah. Now choose the file. And we select the file from, from Python. I have some data. No. Just a minute, my data set. Data set is, sense X. Okay. This is a Python CSV file. I hope it is clear. Then anyone can apply this. Okay, because if you have no SPSS. So same thing. So what's my objective? I am telling you that, just a minute. Okay. Say same thing. And in case of CSV file, you apply pandas. That is simple. Okay. No df1, comma, meta, no need of it. Okay. And when you get this, so the same thing I'm solving, I get very interesting part. Yeah. This is my VIF. Is it okay? It is visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
And just to check, we have taken 9 independent variables. And for 9 independent variables, we get the 9 VIF, and all VIF values are very high, excepting FDI. So FDI VIF is less than 5. I'm telling you, when you go for PCA, pattern analysis, okay, then we consider at least VIF more than 10. More than 10. And definitely, since only the VIF is less than 5, so easily we can discard FDI for factor analysis. And then, again, after getting this, yeah, so many things I have solved. Yeah, after getting this, and 1 minute, after getting this, yeah. I've solved some PCA part. Okay, that part today I'm not discussing. This is now. This is the VIF. And after facing this, just to discard FDI to create another data frame. Another data frame. Question is why? Because for the FDI, VIF is less than 5. So easily you can discard from the PCA or factor analysis. And then instead of how many data we get? 7. So which part is discarded? We discarded FDI, and most probably we discarded, just a minute, 1, 2, 3, 4, 5, 6, 7. That means we have discarded FDI as well as, can you help me? FDI and as well as
CMR, sir.
CMR. Yeah, CMR. That means we have considered maximum high values, because here the two least values is CMR is 16.43, forest is 16.3. So you have this, because when you solve in SPSS or R in Jamovi, actually we discard these two variables. Okay, that's why you discarded CMR and FDI. And in this way, you calculate the VIF values, and just you think all are good. Now you go for PCA. That part I'm not showing here. This is only for the VIF calculation. And I'm telling you one thing, that when you go for, since this is a part of linear algebra, so you have to solve this matrix. And I'll give this PPT. Which part is important? Important is that how can you, from the array, how can you compute the matrix? This is the most important. And array from tuple, I can inform, everything is given. Now, for matrix, we have to import library numpy. And then we can apply, because there are 4 properties. One is the addition of 2 matrices, subtraction of 2 matrices, multiplication of 2 matrices, and division of 2 matrices. And just to think, here, this is my matrix 1 and matrix 2, and if we add, automatically this is the addition. Because this is given A plus B. This is A minus B. This is A star B. This is A by B. So simply, we can add 2 matrices, subtract 2 matrices, multiply 2 matrices, and divide by 2 matrices. This is very interesting. Then we can easily convert the transpose of a matrices. Say we have taken A matrix. This is my A matrix. 1, 2, 2, 3, 4. So definitely 1, 2, 2, 3, 4 is the 2 by 3 matrix. There is the 2 rows and 3 columns. And after taking the transpose, we get the 3 by 2 matrix. Similarly, what thing I can do? Suppose I have taken this is very interesting, very interesting. Basically, I have taken, this is the covariance matrix. Why covariance matrix? 1, minus 2, 0 is the first row. Minus 2, 5, 0 is the second row. And 0, 0, 2 is the third row. And this is basically a symmetric matrix. And diagonals are 1, 5, 2. So I want to calculate using this linear algebra, inverse of a matrix. So this is the inverse of a matrix. And we calculate the eigenvectors as well as the eigenvalues. So these are the eigenvectors of a matrices. And this is the eigenvalues of the matrices. And when you get the, since this is the 3 by 3 matrix, we get the 3 eigenvalues. So what are the eigenvalues? First is 0.17157. Second is the 5.828, and third is 2. Okay. And if you take the sum, you get 8, which is called trace of the matrices. So sum of the diagonal must be equal to sum of the eigenvalues, which is very important for when you apply the PCA. And that's why I have shown this. Before starting PCA, you go for the matrix calculation. I hope it is clear. Hello? Hello?
Yes, sir.
So I'm telling you, tomorrow class live. Now I like to stop here. And tomorrow class, the discussion is the very interesting. And before ending my today's class, I like to show you, but this PPT I'll not give you because this is going on for writing a research paper. So only my last part will not give you. Last part only I am showing. Then you can maintain that when you write any research paper, then how we write the Python. Is it okay? Say, I'm opening this thing. This is the, but sorry to say you, this PPT, I'll not give this. So when you write a paper, that is, I'm using some LSTM model. This is basically time series machine learning model developed, and time series analysis on Google Stock to predict the price project. So all the time you have to write what is your final module outcomes, what is your scope of work, what is your module and libraries required. Is it okay? In this way, you write the documentation part. What is your challenges faced, and what is your future scope? And it looks like a research book. And following at the coding steps. So what is, because I have to take the data from Web Finance, so I have to install this package. So I'm installing this package. Actually, so many times I am opening. Yeah. Just a minute. Eh? Okay. I'm installing some package. And this is some external package. Yeah. So after installing this package, now running these, I apply some, I need some NumPy, I need some pandas, I need some matplotlib.pyplot. And definitely, already I installed the package Y Finance. And for this library, I have given a short name YF. So I need this import. And after this, so there is my some stock, Trident stock. So I need this value. And I need this, my history, period max. We need the company sector, price earning ratios, that and the company beta values. These values we need from this Y.Finance. We need the computer sector, price earning ratio, and company beta. We need this. We get these values. And what is the data? So I'm collecting from this data from 2002 onwards, that is 2025, the today's date. Is it okay? Because I am working on today. So there are total 5715 rows and 7 columns. What are the second column? And these are the 7. And now we have started our work. There are so many things, so many graphs, so many models. And this is a completely the machine learning tool for the LSTM model. And you are used so many prescriptive, prescription, predictive model, k-fold validation, so many validation. This is going on actually. And definitely if we work on some LSTM model after publishing, definitely I'll give you. Okay. And so many parts we have collected from Google. But we are writing a one paper actually. Don't mind, huh? Hello.
Hello, sir.
Tell me. So this type of thing, you write the documentation part. Try to maintain. So this is that's why I have shown it, that what you have to do for your research purpose. Because suppose your model name developed and what you have done and what is your final model outcomes, everything you have to write in your own words. What is your scope of work and how many libraries required. And then you can easily, give the research, give into your research paper. Because I'm telling you, those who are checking your research paper or thesis, maybe he or she didn't know the Python, maybe. But if this documentation is given, so at least he or she will understand what is your objective. Okay. So I like to stop here. If you have questions.
Okay, sir. Sir, one thing, not related to your deliberation. The thing is, in the screen, some scribbling are coming. Yesterday, there are some color scratch or something. So who is creating?
Okay, actually, due to my because I am using some board.
No. সেই জন্য নয়. Those who have seen the video or yesterday's lecture, you have seen that some red mark was.
Yeah, red shade is come. I don't know why.
Today also some scribbling.
I don't know. I don't know why. What is the problem? I don't know.
Maybe done by some participants. So it is my request
that I don't know.
Not to do this. And I am not that much technically competent.
I also am not, because I am also the technically.
এটা কি করে এবং কি করে রিমুভ করে কোনোটাই আমি জানি না. Okay, thank you so much.
Okay. Thank you.
And for the participants, please don't leave immediately.
So at least you know from the class how we import the data from CSV and SPSS. Okay. And tomorrow I will show you the probability distribution, discrete, continuous, also the t-test, chi-square, f-test, as well as the complete visualization.
Complete visualization.
Visualization is very important. Tomorrow I'll show you. And tomorrow mainly I'll work on Python data.
So, what I understand, sir, suppose there is a huge file in SPSS or in Excel. To work with that, at first it needs to be converted into CSV file, which can be fed into the Python system.
Yeah. And actually, I'm telling you, maximum for machine learning. When you go for the machine learning, then some extra, library you can import, some extra library, and that note also already I have given that how many libraries required for machine learning and deep learning. That note already I have given. Okay.
So, sir, tomorrow it is your concluding day for this workshop, not for the learning process of we all. So tomorrow it is my request to all the participants also to come ready with your doubts and queries,
Yeah.
as you can reach at a level.
Actually, I'm telling you, basically, my notes, when after the class, if you practice now, then simple, I'm telling you. And I'm telling you, suppose at this age, what I'm doing, some problem I'm facing, just go to the Google and I have purchased so many Python books. And starting
So
from the
many
basic
Python,
to
mean?
so many purchases. I purchased regression using Python. I purchased logistic using Python.
না পারচেজ মানে এখানে পারচেজ করতে লাগছে কেন?
না, আমি তো বই না পড়ে পারি না, আমি সফট কপি পড়ি না।
ও পারচেজ
বই
পারচেজ করেছেন, এখন সফটওয়্যারটা তো পারচেজ করার কিছু নেই।
না, সফটওয়্যার তো না, আমি বইগুলো পারচেজ করে না পড়লে কি করে করব?
হ্যাঁ, সেটা তো আপনার একদম মানে
না পড়লে ওই কি করে বুঝবো
স্যার
যে
একটা রিকোয়েস্ট করাটা উচিত নয় যদিও, কিন্তু মানে আমি ওই মেশিন লার্নিং এর উপরে একটু কাজ করছি, মানে প্রেডিক্টিভ মডেলের উপরে, র্যান্ডম ফরেস্ট আনফিস এর
র্যান্ডম
উপরে।
ফরেস্টের আমি একটা জিনিস চেষ্টা করব। আমার কাছে, আমি বারবার বলছি, I can give the template of all machine learning problem.
হ্যাঁ, এটা যদি একটু কাইন্ডলি দেন।
I'm telling you, I will try my level best that you need some template. What is the template? আমি বুঝেছি তো তোমার কোশ্চেন থেকে, from your question. What is the template? Template means, suppose I want to do PCA. Okay, so what are the steps written in the template? And if you put the data, automatically result will become.
That we need actually.
I know, but I'm telling you why I'll not give. I'm telling you, I have prepared from different sources, but why I will not give? Because if I give it, that is completely mechanical.
Okay, I'll not learn. That's okay.
Don't mind. Completely mechanical.
No, not at all.
But I'm giving a simple concept. Suppose if you want to run machine learning, say NEP-based problem, using machine learning, I'm telling you what you'll do. First, you solve a simple problem, and so many problems of NEP-based are available in Google. Then you solve the problem manually. Small problem.
Okay,
and
sir.
When you go for solving the problem manually, then your automatically step-by-step algorithm will be developed.
Okay, sir.
And then you search for the NEP-based which library is required. Okay.
Yes, sir.
I'm giving simple examples. I hope you understand. Suppose you told me that you are using the random forest. So definitely you have to solve the random forest first. What are the algorithm for random forest? Okay. And why random forest is used? Then can you compare the random forest with the logistic regression, decision tree, and then you can apply some support vector machine. So many, random forest also a classification problem. Yes. Shommo, am I wrong or right?
No, absolutely. You are wrong.
Your voice is
সৌম্য ভয়েসটা পড়ে গেছে।
হ্যাঁ, বলছি আপনি রং, আমার দৃষ্টতা নেই আর কি।
না, আমি কিন্তু বলছি অন্য কারণে, যে if I give,
আমি বুঝতে,
I have the template.
আমি টেমপ্লেট চাই না স্যার। আমি নিজে,
if we discuss individually, I can give the support of template.
I'll give you a call.
If I give all the template to you, don't mind. Then what you will do is you put your data.
I don't want the template. Say I don't want the template, sir. But whenever I have some query,
you can tell me. You call me.
আচ্ছা সৌম্য,
বলুন।
হ্যাঁ, ফার্স্ট থিং ইজ থ্যাংক ইউ ফর বিং হিয়ার। আমার নামটা দেখো বেশ খুশি লেগেছিল আর কি, অনেকদিন বাদে যোগাযোগ হবে। আর তুমি যখন মেশিন লার্নিং রিলেটেড পড়াশোনা করছো, মানে এখনো না, মানে অ্যাজ বিকজ উই আর ফ্রম সোশ্যাল সায়েন্স, একটা হোমোজিনিটি তো আছে। তা আমি কিন্তু এখনো বুঝিনি যে ওই ব্যাপারগুলো, মানে মেশিন লার্নিং, ডিপ লার্নিং কি খায় না মাথায় মাখে, আমি এখনো বুঝিনি।
আমি আমাকে কি can we give the 2 minutes time?
Yes sir.
Just wait.
স্যার আমার মতে যেটুকু মেশিন লার্নিং, ডিপ লার্নিং এ হলো গিয়ে, ধরুন আমি ভুল বললে স্যার আবার ঠিক করে দেবেন, মানে আমরা সোশ্যাল সায়েন্সে তো জেনারেলি লাইকার্ট স্কেলের ওপরে কাজ করি।
হুম
তো লাইকার্ট স্কেলের একটা হলো গিয়ে আমাদের বায়াসনেস থেকে যায় আর কি, মানে আমরা ওই 5 পয়েন্ট স্কেল যে বায়াসনেসটা থাকে এই মেশিন লার্নিং টুলে, আমরা যদি লাইকার্ট স্কেলের উপর এই সমস্ত অ্যানালিসিস না করে মেশিন লার্নিং রিগ্রেশন অ্যাকচুয়ালি যদি আমি বার করার চেষ্টা করি ইনপুট আউটপুট মডেলিং করে, তাহলে এই যে পার্সোনাল বায়াসটা আমার আনসারের মধ্যে থেকে যায় এই বায়াসটাকে আমরা অনেকটা পরিমাণে দূর করতে পারি।
ওকে
মানে যেমন ফাজি ফাজি যদি ইউজ করি, ফাজির একটা ফাজির ডেফিনেশনই হলো গিয়ে স্যার যে ফাজি ইজ অ্যাকচুয়ালি রিডিউসিং দ্য পার্সোনাল বায়াস, মানে আই ক্যান প্রেডিক্ট দ্য মডেল উইথ মোর অ্যাকিউরেসি। তো
ওকে
সেই জায়গাতে আমরা যা করছি সবই ঠিক আছে ইন সোশ্যাল সায়েন্স, বাট উইথ দ্য অ্যাডভেন্ট অফ দিস মেশিন লার্নিং we can more accurately predict the forecast the
My
actual
PPT
result.
is visible.
এখনো নয় স্যার।
নট ইয়েট স্যার, নট ইয়েট স্যার। আচ্ছা সৌম্য, আমি তোমার সাথে পরে কথা বলবো
শিওর স্যার।
যে মানে আমাদের সাথে রেলিভেন্ট আমাদের কি কি জিনিস জানা দরকার এবং সেইটার মতো করে
প্রচুর
কি
কিছু
কোর্স ডিজাইন করা যেতে পারে।
প্রচুর কিছু জানা দরকার, যে কারণে আমি আপনাকে পেয়ে আমি খুবই আনন্দিত।
ভয়েসটা ড্রপ করে গেছে, ভয়েসটা ড্রপ করে গেছে।
ওকে স্যার।
My PPT is visible.
নট ইয়েট স্যার।
স্যার আসছে আসছে।
ইয়েস
Huh?
এসছে,
ভিজিবল, হ্যাঁ হ্যাঁ আসছে
ইট ইজ
স্যার,
ভিজিবল স্যার। হ্যাঁ
Just I am showing my, just I am showing the simple application of machine learning as far I have tried actually. Say, suppose this is my data. And we know
Temperature
cells
and
depending
cell.
on, huh?
টেম্পারেচার এন্ড সেল, ওকে।
Simple, this is my data. And now you apply our regression technique.
হুম
And we get this line, and that is the scatter diagram, so many things we get. Okay. So definitely there is some error. So what is the objective? Now the error is minimized.
হুম
Now again the error is minimized.
হুম
Now this is a no error, more or less.
বাট ইট ইজ নট লিনিয়ার।
But it is not linear.
হুম
So definitely error is less, but it is not linear, complicated model.
হুম
So this is the complicated model.
ওরে বাবারে।
And that machine learning is doing.
yeah,
আচ্ছা
That the machine learning you do. But the
that's why I'm
complexity
saying
is
you
more.
can predict the future more accurately
Yeah. Is it okay or no?
with machine learning. একদম, yes sir, that I only understood through of the machine learning that I am explaining only.
আচ্ছা আচ্ছা আচ্ছা
Okay.
আচ্ছা।
So
মানে
actually
আমরা
that's why,
স্ট্যান্ডার্ড এররকে জিরো
not only
করছি।
that, that's why they
Right.
are using so many, the backward guidance machine method. I know the mathematics. You don't mind, I'm trying at least. I can know something about mathematics of machine learning. So that is the main objective of machine learning. How to reduce the error, and that's why they are applying so many validation techniques, so many, bootstrapping, bagging, k-fold, LOOCB, so many methods they are using only for this thing. And that's why they can handle the big data. There's no need for normality. So many things.
আচ্ছা স্যার, সিম্পল কোয়েশ্চেন, মেশিন লার্নিং, ডিপ লার্নিং is a procedure or a concept?
Actually, machine learning, you can say concept as well as the procedure. Because I'm telling you why. This is a very interesting question you have asked me. That actually, if we go for the learning the machine, that is called basically the engineer's job. But learning from the machine, construct an algorithm development for the machine, that is the engineer's job. And from the machine, for both the algorithm, draw the actionable insight, that is the research. So that is our job. So we will not learn, construct only we need to construct algorithm development and definitely draw the actionable insight.
ও মানে প্রথমে আমরা মেশিনকে লার্ন করাচ্ছি।
হ্যাঁ, মেশিনকে লার্ন করাচ্ছি।
তারপরে মেশিনের যে লার্নিংটা হলো তার থেকে আমরা কিছু নির্যাস নিই।
Yeah, yeah.
আচ্ছা আচ্ছা,
And now so many things, okay.
তাহলে
We hope you are.
রিগ্রেশনেও তাই, কতগুলো ডেটা
Same thing.
দিয়ে আগে আমরা
Actually, I'm telling you, today I have not sent. Tomorrow I will show you another template.
হুম,
Then how the regression technique can be solved in machine learning. There's the technique. Because when you solve the regression technique in the machine learning, so you have to divide your total sample size into two parts. One is the training
Two
part and
parts.
testing. Always.
Yes, sir.
And not only
Always.
that, in the Python code, you have to write, when you divide the training testing code, it is the static or the random. Is it clear?
Yeah. Yes,
And that
sir.
will
Yes,
that is
show us
important.
one
If it is
example, sir.
random, so definitely all time your results are changing.
Yeah.
And that's why what they have done the k-fold validation technique. And since it is a machine learning based on the big data, so they are using the k-fold 10. K-fold 10. Today I'm not discussing. That is a fantastic. And k-fold 10 basically a random sampling method. And using that technique, so they are thinking how the difference between your training error and testing error.
Okay, sir.
And another
Just
problem.
show us little or guide us little bit about basic brief.
Okay,
About.
that I can give you because they are already. I have some PPT on random forest. I have some PPT on the your logistic regression and everything, and so many
No, sir.
PPT I have.
What exactly I am asking, sir? Show us basically the machine learning approach of the regression.
That's why I'm
Taking the
telling you.
training
And
data,
that
training data and
template I will
testing.
help you.
Yeah,
That
training
template I
data.
will help
So
you.
that is
For
that's the
machine
initial
learning regression,
beginner.
what you have to consider.
Yes.
That template I will give you. Machine learning
Show
logistic,
us.
what things you have to consider. Because since our social science, basically we are solving logistic regression.
Yes,
But
sir.
mainly when you go for machine learning logistic, definitely you have to follow the machine learning algorithm. Okay.
Actually it's a C.
Sir, I have a question. Can I ask? This is Dr. Sen.
Hello.
Yes, sir. Can I ask one question?
And definitely.
Sir, when we are applying machine learning, are we getting different result for regression as
Are
compared
you?
to SPSS and
No,
Jamovi?
definitely. I am giving a simple example. Hello.
Yes, sir.
Suppose using regression technique without applying machine learning, you are getting R square 0.7.
Yes,
Okay.
sir. Yes, sir.
Then what I'll do, I will apply some machine learning technique.
Okay, sir.
So what is machine learning technique? We can apply bootstrapping.
Yes, sir.
We can apply bagging technique.
Okay.
Okay. And we can apply k-fold technique. We can
Okay.
apply LOCP technique. So
Okay.
then on the basis of these, we will try to, minimize our error.
So the R square is going to change?
I am giving a simple example.
Okay.
There is a machine learning regression is called the smart PLS regression.
Yes, sir.
Now they are solving. So they
Okay.
are using the machine learning tools.
Okay. But that
But
these
now what this I am telling you, that is my in the last 2 weeks I have given again I have taken some workshop where I have explained what is the smart PLS regression. But here it is not possible. Don't mind, because here I am using only Python.
Okay. Okay.
Very nice question.
Sir, the finally is what you told that suppose with regular software the R square has come to 0.7,
Definitely,
and through
only we
machine
are using
learning
R
after
square and so on.
optimizing or
Yeah.
after reducing the error, whether R square will get improved or not.
Definitely R square improved. Definitely.
Achha.
Not only that, there are so many relationships that due to high multicollinearity in the data set, your high correlation, but the coefficient of the regression is the negative. So many examples. Okay. So this is natural. If you can think this is impossible, because your correlation is highly positive, but your regression coefficient is negative for some variable. So then you have to think why it is. In that case, your simple this conventional regression failed. Then we have to apply some principal component regression or smart PLS regression. And we can check that the smart PLS regression will give the better result than principal component regression, and principal component regression will give the better result over the convenient regression.
এটা লাগিও না, আগেরটা নষ্ট হয়ে গেছে, এটা
Are you
লাগাও।
going to show these different types of regression to us during this?
Smart PLS regression, smart PLS.
We are going to smart PLS regression. Okay, thank you, sir.
Thank you.
Okay, any more question? I think tomorrow lot many questions will come up. And tomorrow it is my request to all the participants, please join in time or maybe before time. Tomorrow is the concluding day. And tomorrow we will be discussing about our future courses of action. And tomorrow the feedback form link will be given in the chat box. And on the basis of your feedback response, the certificates will be generated. So please join in time or before time. And tomorrow after the session, sir will also be there. There may be an open forum discussion. You can give your opinion how we all together can increase our learning process, as sir is there. And sir has also given his full, what should I say, extension of cooperation and promise that whatever be our requirement in future days, sir will be with us. তো এরপরে আমরা কিভাবে কি কি করতে পারবো সেই নিয়ে আপনাদের যা যা মতামত থাকবে সেগুলোও শুনবো along with the formal feedback form. So tomorrow please join all of us in right time and do not leave in between also.
Okay.
And the
Thank
feedback
you.
form will be given tomorrow in the chat box. Okay, sir. Thank you.
Okay. Thank you.
Thank you all the participants. Thank you. So you are ending right now?
Thank you, sir.
Can I
Okay.
leave now? I'm leaving.
Yes, sir. Yes, sir. Good night, sir.
Sir.
Thank you, sir.
Thank you. Thank you.